Hey guys, Mr. Ferguson here on Wrestling with Math, and today we're going to evaluate an exponential growth and decay problem. Okay, so my example here, it says if you had $5,000 and it grows at a rate of 2% per year, what is it worth in 6 years? So if you notice, I have my formula up at the top. I do have the plus and minus because I'm unsure which one I'm going to use right now, and then I have my description as to what each variable represents. So $5,000 grows 2% per year. What is it worth in 6 years? Is it growth or decay? Well, we're looking for our key terms here. Grows, okay, means growth. So if I did have to determine whether it's adding or subtracting, well, the word grows, maybe it says increases by, appreciate, if we're talking about some sort of money or real estate. So here, I'm going to use P1 plus R to the n. Okay, I'm going to put A equals here. Again, R is your rate or ratio written as a decimal, and n is the number of years or the term number, depending on if we're doing geometric sequence or this here. So P, my starting value, is $5,000. 1 is just the number 1 plus 2%. I don't just plug in 2, I have to turn this into a decimal. Two ways: I can divide by 100, or I can move the decimal to the left 2 spots. So this will go in as 0.02. And n is the number of years. It may be t, because it could be term number or number of years in a time. It's going to be 6. So I am going to use my calculator. You can, for at least this example, get away with using a basic calculator. I recommend using either the calculator on Delta Math or one of the graphing calculator apps if you do not have your own graphing calculator. I'm going to plug this in, 5,000, 1 plus 0.02, and I'm going to raise it to the 6th power. And I'm going to write this out here, 5630.812. And just be careful with what we have to round to. I'm going to round this to the nearest cent since we're dealing with money here. So that's 2 decimal places. So I'm looking at the 1 here. Does the 2 bump it up or not? The 2 does not bump it up, so this would be worth $5,630.81 after 6 years. Okay, that is a growth example. Okay, so if you do need to go back, feel free. I'm going to do one more example with a decay. So let's get rid of this. And since cars are something that decays, let's say you bought a car for $16,000 and it depreciates 8.25% each year. Okay, what is it worth in 3 years? Okay, well, am I going to use growth or decay? Am I going to use the plus or the minus? The word depreciates, goes down in value, so that means I'm going to use decay. P1 minus R to the n or to the t, depending on the problem here. Again, this formula is not going to change. So my starting value is 16,000. Okay, nice new car. I drove it off the lot, now it goes down. 1 minus, I need to turn this percentage into a decimal, and some people will say, well, it's already a decimal. Well, nope, the percentage sign is still there. So the 2 ways, again, divide by 100, or you can move the decimal point to the left 2 spots. So 0.0825, and this was 3 years, so I'm going to plug that in. Again, go right to your calculator, 16,000, 1 minus 0.0825 raised to the 3. And this is, and again, I'm going to write this out, and then I'm going to round 12,357.715. Since we're dealing with money, again, be careful with what they tell you to round to. I'm going to use nearest cent or 2 decimal places. So I'm looking at the 1. Does the 5 bump it up? Yes, it does. So this car is now worth $12,357.72. Again, look for those key words: growing, decay, decreasing, appreciate, depreciate, whatever it may be, to determine which one we use. And again, that rate or ratio must be a percentage, must be written as a decimal when we put it into the formula here. If we're just determining what the percentage is, well, then we'll leave it as a percent. So here's 2 examples for you guys. Hopefully this helped, and thanks a lot, guys.